Hello and welcome to my third Max tutorial. My name is Robin Palmer, and today I want to show you some techniques for initializing your patcher. I'm going to show you 4 different techniques, starting with the most obvious that you are no doubt aware of, but progressing through to more sophisticated and powerful ways of handling patcher initialization, ways that are more robust, more obvious, that give you more control, and so on. As usual in Max, there's more than one way to do everything, and sometimes it takes a bit of experience and a bit of investigation and a lot of just trial and error to find ways that are more suitable. So that's one of the things I'm hoping to do in these tutorials, is share my experience with you. It doesn't mean that I have the best way. Sometimes my solutions may not be your solutions, but the more tools you have, the better off you'll be. So to start with, the most obvious technique here, if I create two objects that you're well familiar with, whoops, not a comment. Here's a load bang and a load mess. And these objects fire when a patcher is loaded. So they're the most obvious way to solve this problem of patcher initialization. So the load bang sends a bang. So I'll just set up a graphic there, and load mess, if we give it a value 20 as a float, we can fill a typical little float input with that. And sure enough, this will work just fine. We can use load mess for any type of value that we want. We can, for example, send it just an integer 1 to turn on a toggle. What else might we want to do here? How about a slider? We can set up a slider with some sort of initial value of 0.5, which we'll want to be halfway, say the median point of the slider. And actually, maybe I should point out something here about how I initialize objects. I like to constrain the values immediately, and you do that over here in the inspector. So for a float, I'm going to just say I want positive values 0 to 100. I'll put those in as the minimum and maxima, and then as I edit, I can't edit this box outside that range. So say it was choosing frequency. I can't have a negative frequency dictated by this. Constraining your values is just a smart way to prevent bugs and to ensure the robustness of your program. So every time I put down a float or an int in a working program, I constrain it. I may not do that every time in these tutorials, because for time reasons and because I want to focus your attention on other aspects. And if you look, like, sliders are the same. I mean, a slider starts being an integer value up to 128. But if you check the box, then you turn it into a float value instead. And I always use the range 0 to 1. So if you hook up a box here, we can see now that the values indeed go from 0 to 1. Okay, why do I do this? I don't like anything hidden. I like all the code to be as explicit as possible, which is difficult in a visual language because the properties panel hides lots of details about this slider that's important. And rather than having to guess all the time, what are the constraints, what are the values, I just make all my sliders, with few exceptions, 0 to 1. Then I know. I don't have to guess, I know. And if I want to scale them to other values afterwards, that's very easy to do. And it will be explicit because that scaling object will be explicitly in my code. So this is just an example of how I like to provide consistency throughout my program. So a bit of an aside, but I think important. So these all work. I can double click a load mess or a load bang, which simulates what happens when the patcher is opened. And you can see that all of these different sorts of controls set to the values that we expect. Now, as I go through these methods, I want to note the problems or the characteristics of each so that you understand the whys and wherefores. And I would say One of the main problems with this method is that these initializations with load mess and load bang can be spread out all over your program in subpatchers and abstractions and so on. And the second problem, which is not so obvious perhaps, is that the order of these is not guaranteed. We have no way of knowing which one of these will happen first. And this is not always a problem with initialization until you get into more complex situations. And then you definitely want to always guarantee the order in which things are happening. So I'm actually just going to save this here. I don't know what to call it. Tutorial 3, I guess. Just something generic. Just so I'm saving my work as I go. So this is the first method, and it's the most obvious. It's got problems. So let's look at how we can solve some of these by looking at other ways of working. The very next idea I had when I looked at this was I thought, let's create a reset. Let's just create a reset button. Like in this case, I'll just use a simple message box for that. And this will act as a central place where I can control all of this initialization. So I'm going to send and receive this reset message wherever required. And one of the things I do to make these pop out of my code is color them. So sort of like this, find the right bunch of colors. So this taupe color, for example, I use quite often for send and receives. And that way I see them when I look at the patcher, because it's important that you don't get confused. I don't like using send and receives for this reason, that it sort of hides the flow of a program. But for a general reset where you want to access many places in your program, it's just what you're going to have to do. So this reset, for example, is going to trigger a message 0.5 for our slider. And similarly, I'm going to replace all these load bangs and load messes here with appropriate values. Now remember, these are all side by side in front of us in this example patcher, but in a working program, they might be in different abstractions, in different subpatchers and so on. So that's why I need to use multiple receives for the reset, just to make that obvious. Why I'm doing this. Whoops. Connect it up to the left input of the message. And I can send just the integer 1 to our toggle. Like that. And I think that's pretty well it. So now I can put one load bang. Instead of multiple load bang, load mess, we just have one in our entire program. So this centralizes that functionality and makes it more obvious. That's going to send a message out to each one of these. If I just change them, and we can see it worked. Hopefully you saw the bang there, flash. So what are the problems, or the characteristic, I guess, they're not all problems necessarily, but what are the characteristics of this method? Well, the initialization is no longer hidden and spread out. It's one load bang, it's one reset button. You can put that at the top of your code. It's quite clear. But the order is still not guaranteed. We don't know, all these resets here, we don't know when these receive objects are going to receive the message, actually. We don't know in what order that's going to happen. I think it happens in the order you created them, in fact, which is like pure data, but it's not explicit. We cannot guarantee it. That's a big problem. That's a problem that I'd like to solve. So the next method is an approach that will simplify this even further. And this method uses a built-in function of message, which I didn't know about for quite some time. And then I discovered that if you use a semicolon syntax, the message actually has a special function. So what you can do is set up names of receive objects, set slider, for example, just arbitrary names. So I'll set slider, I want that to be 0.5, and set bang, you can just use the word bang to send a bang message. And set float, we have 20 for that. And just make sure you've got a semicolon at the end of each of these lines. You can define as many as you like. I'll put in set toggle. And there, that's our message. So we no longer need this send object. Instead, we hook our reset up to this message, and it is going to send to each of those 4 places, which doesn't really save us much, I suppose, except that it's all very explicit here in the message box. So using this method now, instead of having one receive, I need to define the receives as we specified them before. So I'll just change these from reset to the individual names very simply. So I've got the same number of resets, but now they all have unique names, which is no big deal. But the message box here has the values that we want for each one, and that is the big advantage. We don't need these here anymore, spread out around our program. So we can just delete them and explicitly connect up. Now, there's nothing much I can do with the bang there, so I'll just leave it as it is. So this is the third method, and it solves this first problem up here. Initialization is also using this method no longer hidden and spread out. It's also going to be much easier to change any of these values because all we have to do is go to this central place, this one message box, and edit and change our values. And furthermore, finally, we have a method where the order is guaranteed because this message works sequentially top to bottom. So we've solved that problem with this third method of initializing our patcher. Now I have to mention as an aside that this special syntax of the message box causes a big problem in Macs. Because a semicolon now has this meta meaning, we can no longer use semicolons in message boxes. And this is a problem when we're parsing data from various sources that might use them, or even just normal symbols where you might actually use the, that punctuation in normal text. So it's kind of a pity. I view it as almost a mistake that the semicolon has this special function. I mean, they could have chosen a character that at least wasn't part of normal English punctuation, but we're stuck with it. It is one of the reasons why I don't recommend Macs for text processing. This question comes up over and over, and problems come up over and over. But anyway, so this third method works perfectly fine, but I'm nonetheless going to show you a fourth method that's slightly more sophisticated, and then I'll explain why I prefer it. But I should say there's no real reason not to use this message syntax. It exists, it can be used, it's quite handy. The fourth method involves a collection. I love call, I use it all the time. In this case, if we define a collection just called init for initialization, and we can put the material that would normally be in the message box in here instead. So I'll just change the format slightly so that each line is correctly formatted with an integer index. There we go. And the semicolons stay at the end of the line. No worries. So each one of these lines is an initialization, and you can have as many as you like. So I'll close this up and save. So that's in there. Right, now how are we going to use this? It's not quite so easy as the message box. We're going to have to build a tiny bit of code. First of all, we will put a load bang so that this can be initialized. And actually what I'm going to do is not use a load bang, but when we initialize, we want to dump all the material out from the collection, every line, sequentially. So I'll actually send it a dump message and put a bang there so that we can trigger that at any time during our debugging process. So Dump is going to send all the values out the left outlet of collection. Give us a bit more room here. And it sends them out as a list, so one item after the next sequentially. And that list is composed of two things. We've got the set slider part, and we've got the rest. So I'm going to use one of our fancy list processing functions, nth, ZL nth. ZL is our magical object that is just brilliant for processing lists. And nth says, take this item, the first item, out the left, and all the rest out the right. So it actually splits. It's not just a matter of taking one value. It actually splits the values. So first what I'll do is I'll make some space here. A lot of space. So all the subsequent numbers like the 0.5, the bang, the 20, whatever they are is going to come out this right outlet. It could be a list of initialization values, not just a single value indeed. Here they're all single values, but even if it was a list, this would work perfectly fine. We're going to send those into a message box just to save them for now. And what do we want to do with the stuff out of the left? Well, we want to do two things with this symbol. So we'll set up a trigger for that. We need to send this message off somewhere based on the name set slider. So we want to be able to send to an arbitrary receive object, and we use the object forward for that. And if we send it a message that starts with send, it will indicate where we want to send the message. So I'll set it up like this. So for our first item then, say set slider is going to come here. It's going to become send set slider. That's going to be going into our forward object. And that says send any subsequent input to that receive object. So forward works a bit strangely. First you tell it the destination, then everything it gets after that will go to that destination until you give it a new destination. So this is both handy and strange at the same time. I mean, I might have liked it better if this took, say, a list of destination data. That, that would have meant that you don't need to send multiple inputs to it. But that's the way it's implemented, and it works just fine. And we can work with that here. So what I'll do, we already have the destination part then defined and being sent to the forward object. So the next thing I need to do is actually send the data through. So that is the bang part here of the trigger. So I will bang my data. I'll also send that through to forward, just clean up a bit here. And I'm using the context menu, the right click menu, so you can see explicitly when I'm doing things. I do use some hotkeys, but for the purpose of the tutorials, it's nice if you can actually see a little bit more what I'm doing. So something we shouldn't forget with our collection is that we're storing this initialization data. We want it to always be available to us every time the patcher loads. Normally, call will actually forget any information in it unless you check this. And then it will save the data with the patcher, which is definitely what we want in this case. So don't forget to do that, otherwise there's no initialization data to work with. Okay, test. Yes, I like testing. So let me reset all these, and then I will test. Boom, it works. No worries. We no longer need this message here that was used in method number 3, but method number 4 that we're on currently, we can just, we can still set the reset message up. And then all this stuff can actually be hidden away. We don't need to be looking at this all the time, so I'll encapsulate that into a subpatcher, which I will also call, for consistency, init. And there, that's all we need. So method 4 is quite neat and tidy. You can click here, boom. Everything resets based on what's stored in the collection. And the collection and the other code is hidden away in the subpatcher, which is nice and tidy. So what about the characteristics of this method then? The initialization is no longer hidden in one sense or spread out. I mean, it's all in one central place inside the call. Anytime we want to look at it, we can. We could just go in here and go double click. There it is. It's all in one place. It's easy to change. So if I decide I want to send something else here, I can just add a new line to the collection. Let's say I've got an LCD panel and I want to send it some information. I can't remember what you send to an LCD panel, but there's a coordinate that I'll send. And it's even possible to send multiple initialization items to the same object. So let's say I want to send LCD also a name, my name, a string. You can do that as well. And this is a nice advantage of this technique. This is why I indexed using these integers, in this case 1 through 6. It might have seemed more logical to index this with the set slider, the set bang, and so on, with these symbols, which we could have done, but then you can't have more than one. You can't have more than one set LCD, because if that's a unique index, that's a conflict right there. So using these arbitrary numbers is actually better. It gives us the ability to, gives us just more flexibility in here for how we're going to set up the data. We could set LCD, do a few other things, and then reset the LCD even, because we have full control over the order of events here. And sometimes you need that. So that's nice. So it does have this second characteristic. It's easy to change from a central place. And the order is also guaranteed and fully under our control. So to summarize then, we've looked at 4 different methods, starting with the simplest, just simple use of load bang and load mess. And secondly, using a central reset and dispatching the different reset messages out across our application. The third method uses the built-in message with the semicolon syntax, which gets around several of the limitations of the first 2 methods. And finally, we have this method with a collection. And it doesn't, on the face of it, have any advantages over the message syntax, except that you can save and restore text to a collection. So this means you can actually set up your initialization conditions in a text file outside of Max and have that read in as some sort of configuration file if you wish to. Using collection gives you all these advantages, whereas having the text embedded in a message itself does not give you the same amount of power. So even though functionally it doesn't seem to give us any benefits, and in fact took a bit more code, I prefer using collections for any sort of configuration information. Right, so I hope this has helped you. Again, the purpose of these tutorials is to take people through from the more obvious beginner techniques into less obvious sort of intermediate level techniques. You can choose the best technique for yourself, but to have a toolbox of different ways of doing things is very important, especially, as I'm trying to emphasize, is the why. Why use this method? What are the advantages? What are the disadvantages? There's no absolute truth in any of this. You want to choose the best method for your application at the time. So thanks for watching. My name's Robin. You can join me not only on YouTube for these video tutorials, but on Patreon, where I also post patches and lots of textual information. Please comment. Let me know what you like, what you'd like to see. There's so much more that I have in mind to put across in these tutorials, but I'd like to do stuff in the order that you prefer and address the topics that you prefer. So the more input I have, the better, really. That's it from me for tutorial number 3. Happy patching, and I'll see you again.